Good morning, class, and welcome to another interesting edition of Maths with Ablight. A pile of paper contains 100 sheets. Find the minimum mass of the pile of paper. Hello, class, and welcome to yet another interesting edition of Maths with Ablight. We're still looking at numbers for year 10. We're playing with different numbers. And the question before us today says, calculate the largest possible area of a square whose length is 1 centimeter. Solution. Now you have been told that the length is 1 centimeter. But in dealing with this, they've given you the exact length of that square. But we're going to deal with the upper boundary because it says the largest possible area. That is why we'll be dealing with an upper boundary instead of dealing with the exact figure. What that means is that the length, as seen from the question, is 1 centimeter. So the upper boundary will be equal to 1 plus 0.5. And that gives you 1.5 centimeters. And now a square is that shape, a four corner shape that has all the four sides equal. So if I draw my square, I could have something like this, this side equal to this side, equal to this side, equal to this side, and all of them will now be 1.5 centimeters. So that is a square. What is the area of a square? The area of a square is equal to length squared or breadth squared. Anyone can you want to use. So the area therefore is equal to 1.5 raised to power 2. So you get your calculator at this point, and when you do that, you get 2.25 centimeters, and that is your answer. So this is the largest possible area of a square that has got a length of 1 centimeter. If they didn't say the largest possible area, if you've been asked to find the area, you just use 1 times 1 or 1 squared. But if they tell you to find the largest possible area, add 0.5 to get the upper boundary, and then you solve from there. The next question says, what are the common factors of 42 and 56? We did something like this in the previous class. This is very simple. You write your solution, then the factors of 42. You can list them out if you want to. You have 1, 2. These are numbers that can go into 42 or that 42 can be divided by, and there is no remainder. Can 3 go into that? 3 here, 1, 3 into 12, 14. Yeah. Sorry, I'll get a calculator to confirm that. You're allowed to use calculator for this. 42 divided by 3 at 3 is equal to 14. So 3 can go. I doubt if 4 can go, because if 2 goes into it is 21. If 4 is going into it, it's going to give you 10.5. So 4 cannot go into it. 5 cannot go. 6 can go, because 6 times 7 is 42. 7 as well can go into that. I think 14 can go. 21 can go. And then 42 is the final factor. Then for 56, what are the factors? 1 can go into that for sure. 2 can go. Let's try 3. 3 into this place is 1. Remainder 2. 2, 26. 3 cannot do it. Let's try 4. 4 here is 1. Take 1 to this side, 16. That's 14. So 4 can go into that. 5 cannot go because 6 is at the edge of it. Can 6 go into it? Let's try. 56 divided by 6. It cannot go because it's having a decimal point. 7 should be able to go because 7 times 8 is 56. I'll check that to be double sure. Yeah, lovely. 8 can go. 9 cannot go into it. I think 14 can go next. Let's see, 56 divided by 9. It cannot go. You have a decimal point. 56 by 12 should give a decimal point as well. Decimal point. So the next number is 14. Have we tried 13? Let's try 13. 56 by 13. Of course, it shouldn't be able to go in. It's having a decimal point. Then 28 can go. And then 56 should be the next one. So we're going to find out the ones that are common, because the question says what are the common factors. Having listed everything out, you are going to circle the ones that are common to both sides. 2 is common. There's no 3 here. 4 is not here. 6. Let me check 56 by 6. 6 is supposed to be there. 56 divided by 6 is what? Oh, 6 cannot go. Okay, 7 is here, 7 is there. 14 is here, 14 is there. So we have 4 factors. So common factors are 1, 2, 4, 7, sorry, and 14. And that is your answer. Then we'll take another example of numbers. It says, Frank thinks of a 2-digit number such that the first digit is 6 more than the second digit, and the number is prime. What number did Frank think of? 2 things are here. 6 more than, in fact, 3 things. 2-digit number. 6 more than, that is the first number or first digit being 6 more than the second one, and then the word prime. I'll start from here. A prime number has 2 factors, itself and 1. I've defined that in the previous videos, in some of those previous videos. Now, we want to establish 2-digit numbers. 2-digit numbers are numbers that range from 10 to 99. 10 is 2-digit, 1 and 0. 11 is 2-digit. 99 is 2-digit. If you say 100, that's 3 digits, so it doesn't follow. So these ones are 2-digit numbers. The numbers now must range from 10 until 99. That's the first thing to establish. Now you are going to ensure that the 2 numbers or the 2 digits are such that in the arrangement, the first number, yes, is 6 more than the second number. It is simple. You are going to start with 6. If you start with 5 or a number less than 6, you will not get the right answer. Starting with 5, 5 cannot be 6 more than any number. So start with 6. So the numbers, or you say possible numbers, are 6. What number is 6? 6 more than itself. I don't know how to put it that you will understand. The second number is such that 6 has to be 6 more than that second number. So what number comes to mind? It is 0. Because 6 is 6 times bigger than 0. The next number would be 7. 7 is 6 times bigger than a number. What number is that? It is 1. You keep increasing. The next number will be what? 8. What number is 8 6 times bigger than? It is 2. Then you go on to say 9. What number is 9 6 times bigger than? It is 3. So the numbers or possible numbers are 60, 71, 82, and 93. Then the second part of the question that is tricky says the number that Frank is thinking of is prime. What are prime numbers? Prime numbers have got only 2 factors, itself and 1. No other number can divide it without a remainder except itself and 1. When you go to 60, 60 can divide itself, 1 can divide 60, but 60 also has other factors which are 2, 3, 10, 5, 6, even 30, 15. They are all factors of 60. So 60 cannot be the answer. You can start that one if you want to. Now you consider 71. 71 is most probably going to be the answer because it can divide itself and 1 only. No other number can divide it without a remainder. You take it good first, leave it and try the other numbers. Here, 82 and 1 can divide themselves normal, but 4 can go into this. Sorry, 2 can go into this. I think 41 can go into this. A lot of other numbers can go in. So you cannot use this one. So this is out of the question. Then you try 93. 93 and 1 can divide themselves, but 3 can go into 93. And some other numbers can as well go. See, this one is out of it. So you can now say, therefore, Frank thinks of 71. And that is your answer. Write 79 over 30 as a recurring decimal. Now the solution is simple. You go into long division. Yeah, you go into long division. I want to give you some space. You write your 79 and 30 here. 30 goes into 79. It's going to give you 2 times. 2 times 30 will give you 60. You subtract. When you subtract them, you get 19. 30 into 19, it cannot go. So you put a decimal point here. Then add 0 once you put decimal point. 30 into 190 will go there 3 times. Sorry, 6 times. 6 multiplied by 30 will give you 180. You subtract. This minus this will give you 10. 30 into 10, it cannot go. So you add another 0. 30 into 100 will give you 3 times. 3 multiplied by 30 will give you 90. Subtract again, you get 10. 30 into 10 cannot go. Add another 0. 30 into 100, 3. 3 times 30 will give you 90. You subtract again, and then it continues like that. At the end of the day, you are going to subtract it down, down, down. You just be getting 0.3333. And the question says you should write it as a recurring decimal. This is the answer. Write it as long as your book can take. Even if you write 3 to this point, the answer is correct at this point because it says as a recurring decimal. It does not end. So this is what they want you to do. And this is your answer. So we'll leave it at that. Thank you. And in the next class, we'll take more examples. Have a great day. Bye.